This is the motion graph reteach lesson to go with the motion graph quiz. The way that we'll do this reteach lesson is to just go over a few of the most commonly missed questions, starting with this one. The question reads, what is Maria's average speed during her entire ride to work? So we're looking for her average speed from position A to position F. First thing that we're going to do is look at our distance, because average speed is equal to distance divided by time. So from position A to position B, that's 5 miles. From position B to position C, that's 5 more miles. And from position C to position F, that's a distance of 20 miles. So 5 plus 5 plus 20 give you 30 miles. And the distance that the time that we travel on our horizontal x is 10, 20, 30, and 40 minutes. So we have 30 miles for our distance divided by 40 minutes for our time gives us 0.75 miles per minute for our average speed. The next problem reads, after Marie returns home, what is her average speed for the rest of her trip to work? So again, going back to the previous problem, the story begins at 0 distance and 0 time with her leaving her house and going to work. So from A to B, she leaves the house for a little bit, for 5 minutes approximately, and then line segment BC shows her returning to work. So when this problem is concerned with her average speed for the rest of the trip to work, it's looking from this point of the graph over. This is the portion of the story that we're concerned with from point C to point F. So if we want to figure out the average speed, we're going to need to know the distance that she travels and the time. So from point C to D, and then D to E and E to F. So if we look at the total distance that she covers from C to F, that distance is going to be 20 meters. So she goes from 0 to maybe, I don't know what that would be, maybe like 7, and then she rests for a little bit, and then she travels the remaining 13 meters or so, but you're looking at the total distance that she covers, so that would be 20 miles rather. So 20 miles is the distance, and then the time that it takes for her to cover that distance. You could do this a couple different ways. You could look at where she ends up at, which is 40, and where she starts out at, which is 10, and you could say 40 minus 10 gives you 30, or you could just count and just say 5, 10, 15, 20, 25, and then 30 minutes. So 20 miles divided by 30 gives you 0.667 miles per minute for this problem. Alright, our third problem. How many minutes does Barry finish the race after Kim? So they are racing to a distance of 10 kilometers. That's where the finish line is, where I highlighted in yellow there. Barry is in blue, and Kim is in red. Tells you how many minutes does Barry finish after Kim, so it tells you that Kim wins the race, and you see that here because she reaches the distance of 10 kilometers after 50 minutes. So Kim finishes in 50 minutes. Okay, Barry is right here in blue. And if I draw a line down to the time that he finishes the race at, he finishes in 60 minutes. Okay, so how much longer is 60 minutes when you compare it with 50 minutes? That's right, it's 10 more minutes. So Barry finishes plus 10 minutes after Kim. More problems. What is the total distance traveled in the graph pictured below? So the best way to tackle a problem like this is to break it down one segment or one section at a time. So we start out here at 0 distance and 0 time, and we're just concerned with the total distance. Alright, so to go from point O to point A, that's a distance of 10 meters. So 10 meters. Nothing happens from A to B. Doesn't cover any distance. You stay at 10. You're just at the rest position. And then from segment B to C, you're going back down to the start. And you're starting at 10, and you're going to 0. Okay, so that's a distance of 10 meters that you travel. Rest some more. Distance doesn't change, just time goes by. And then we're at segment D. And to go from segment D to segment E, we're going to travel this direction. And the distance that we begin at right here is 0, and we end up right here at the 5-meter distance, and all I'm doing is just looking over here. So for that section, it's 5 meters, and then we rest some more from E to F. So when I just go ahead and add this up, 10 plus 10 plus 5 gives me 25 meters total. Last one. Describe the speed of segment OA to this segment DE. Okay, so here is OA right here. The distance that we travel starting at 0, ending at 10 meters distance, and then we're going to divide by the time, so I'm just going to go down here. Ooh, that's not a very straight line. Okay, but that's where the point would be if I would draw it straight down. So that's between 4 and 6 seconds, so that would be 5. And if my math is correct, that's 2 meters per second. When I compare that with segment DE, right here, the distance that I travel starting out at 0 and ending at 5. So the distance that I travel is 5 meters. I'm going to divide by my time. I start out at 16 and I end up at 21. So that is 5 seconds. And when I divide that out, it is 1 meter per second. So you could honestly look at the red line and say that OA is faster or more rapid because the slope of the line is more steep when you compare it with DE or the blue line, which has a more gradual or gentle slope, but here you have the math to compare the two together.